Okay, so now we'll do show and tell.
So, we must have about 100 people here. This is the Nito bot vac, and it has a Raspberry Pi inside with a cell phone battery. And you can see me walking around here. That's our LiDAR. It's a two-dimensional LiDAR. It'll see out to about 6 meters. Regardless, what I've done with ROS, and this image you see here is called RViz, ROS Visualizer. It's a 3D, three-dimensional map. It's nice. And there's that. Excuse me while I clear the screen. Oh, here's something that's cool. Bear with me. Where's the crap canvases today? I don't see them, huh? Bear with me. Let's see. ROS, breaking it down. There we go. So some stuff you can do in ROS. First off, you'll run the ROS core. But let's say we want to see what the nodes are doing currently with our bot vac package. Incidentally, the HBRC has a special interest group that meets with the Silicon Valley ROS group the penultimate Wednesday. We're having a great time at the shop. I shouldn't mention this because seating is limited. But anyways, we're learning ROS, and a lot of this is on the bot vac. And so here, what was I going to do? I was going to show you.
The packages are on the GitHub.
Oh yeah, and it's intro to ROS. You know, the standard trainer for ROS is the TurtleBot, and TurtleBot costs $550, and this one vacuums the floor. Seriously. So here's the active.
This has been a paid announcement.
Yeah. So let's see here. Regardless, these are the nodes, and basically ROS is a publish subscribe architecture. And here you see the various publishers and subscribers on their threads. The messaging is passing through the threads. And with our robot, you plug into the USB and you have access to the wheels and the encoders and the LiDAR scanner. And what Michael Ferguson has done for us, and Ralph Ganock has improved, is the way this is implemented. Mike did the original work, but Ralph has packaged it up with launch files so that one command launches several nodes. And he's also added the model to the RViz visualizer.
And I may add that since it is in a public GitHub repository, pull requests are honored. So recently we've added looking at the intensity of the LiDAR return in an effort to devise a way to find an object so we can retrieve an object and then do phase 3
That's our FloorBot challenge.
Of the FloorBot challenge.
Also, Dr. Alan Fetterman has a voice control for the bot vac, so you can tell it to go fetch a beer, and it'll go there. But it can't really open the refrigerator door and fetch the beer here, folks. So,
yes.
Yeah. And who is it? Michael Wimble here. Raise your hand. There you go. He's got a. The stuff's in here that's not hooked up yet, including the bumper, the drop sensor, and things like that. So he's written a package for the bump sensor. It's kind of funny because now he's navigating and he bumps into something. The terminal window says, "I heard a bump." Now, unfortunately, we haven't told MoveBase about the bump yet, the path planner. So it's a case of the more you know, the less you know. So without any further ado,
there's a package now that will.
Wayne, I know. Go ahead.
There's a package now called Move Basic that if it detects an object in front of the robot, it'll wait to see if the object clears, and if it doesn't clear, it'll give up.
What's that called?
Move Basic. That's on the Ubiquiti.
Is that different than MoveBase?
It is different than Move Basic. It is a simplified package.
So here's the deal: is first I drive it around, and I create the map box, and I save the map, and I kill G mapping, grid mapping. Be sure and save the map before you kill G mapping. Then you load the navigation stack, which includes move base and the localizer, and it loads in the map that you just saved. So this is that map, and without any further ado, I shall click 2D nav goal and point, press, and drag the orientation or pose I want of the robot. Here you see the path planning line. Absolutely nothing up my sleeve. Wayne, the robot's navigating. That's for you, buddy. you can applaud. Oh, you're going to wait till he gets there, huh? You don't believe me, huh? What's that thing? Here, Danny. Oh, what do you do now? You do the Fortnite thing, don't you, or something like that? There you go. The kid's got it.
You put them in.
Okay. All right.
Let's see what.
Oh, we got trouble. We got trouble here. Right here in River City. No. We'll check my path planning here. Shouldn't be a problem at all.
It should detect it pretty soon.
Not room for the two of us here.
Not the club will have to pay him $3,000.
Oh, now it sees it. Oh, it's going to pass around it.
You cannot stop me. Oh, wait a minute. I don't want to encourage you.
It's going to make it. It's going to make it.
Yay! Kind of exciting, huh? We're easily amused, folks. Okay, so you see now he's turning to get the pose that I set, and this is navigation going from one place to... Whoa, no, he just teleported. How about that?
He adjusted, yeah. No. He fixed his position in the map.
Oh, that's interesting.
Now he's lost.
It was all going so good.
I think you got it.
You got it.
So what you do in this case is you go to pose estimate and tell him that he's over here, dude. Oh, you're over here, kind of, sort of. No, pose. And my pose is right about here. I'm resetting the pose. And let's go back to that clear cost map, one of my favorite vices. Let's see here. Boom. Ooh, that table might be a problem. You know what I'm going to do? I'm going to set a different goal. Here, let's go over here. Let's see how that works out. All right, we're not going to spend too much more time with this.
No, it was successful.
Clear the cost map for you.
Thank you for that, David.
Somebody walking.
Oh, you're good. Here he's trying to localize, which is kind of silly because the LDS sees in 360 degree. Although I do notice that it gets some kind of resolution when it spins. So, okay, that's cool. Oh, I just...
Spin recovery worked. It's a first, ladies and gentlemen.
Let's focus there. Oh, shit, I didn't mean to. Bear with me, folks. Here. Interact. Okay, here we go.
Success, move on.
Is you can actually see the LiDAR scans. You see them? Wow. You see that? Thank you very much. Okay, I'm done now.
Are you done amusing yourself?
Yeah, I'm done amusing myself. Hopefully I've amused some of you also. Thank you very much.
So I am building my 14th robot. And I think it might be called an 80. I number mine or name mine alphabetically as I go along. And if you're on Facebook and follow me, you can see the progress on this thing. But all I'm bringing today is the compute plate for it. So if your robot is using a propeller computer and you're thinking, yeah, I need something a little bit faster and maybe Arduino still doesn't do it, you might want to move up to this. So this has on it, this is a up-squared computer. It's an Intel computer, quad-core, 2 or 3 gigahertz. Has a Pi 3 Plus, B3 Plus. This is the USB hub. This is the Ethernet hub on this thing. This is one of the recording hard disks that'll talk to the up-squared. On the other side are 2 up Generation 1 boards, also Intel computers. And just in case you don't have enough computing power, this is a NVIDIA Tegra TX2. I think it has a teraflop of computing capability on this thing, and another disk to record everything that's going on. This is the connector to the disk on this thing.
That's turbocharged on the floor models, right?
That's right. So this will be responsible for reading the on-off switch. The rest of this, yes.
How long is your extension cord of the robot?
I have a 1 kilowatt hour battery from an e-bike, 36 volts, 30 amp hours on this thing to power all of this. 8-inch wheels on this thing so that I can get up over the lip of my house. Its immediate goal is to travel from the living room to the refrigerator and grab not a beer, but a half-gallon of milk. So I've worked out a little bit of the physics involved, and I will not be using motors to operate the arm, which the motor to hold that much torque at that distance runs starting at around $400. Instead, I am going to be using linear actuators, which you can get for about $35 and can generate about 400 pounds of force and can fully extend in like 5 or 6 seconds, something like that. So a bunch of linear actuators, and then I need something to grab the milk.
But you have to promise not to cry if the milk's
Chris, can you take away his gold stars? That's it.
Good we get stuff.
So this is DroidBot. It's been here before. I'm actually not really here to show DroidBot. It's holding a little teeny board that plugs into USB that has an ARM M0 on it, a accelerometer, a gyro, a magnometer, and some analog ports and so forth. Nice little tiny thing. You plug it into USB and boom, you got a little subsystem. So that's really what I'm showing. But the other stuff is pretty cool, you know. So it has a LiDAR on top, similar to what Camp was showing, and it has ROS, and it's running a Raspberry Pi 3 Plus, and all that kind of fun stuff. So it's a nice little capable bot, but I'm just going to make it go forward a foot and back a foot. So that's not exactly very exciting to you guys, but to me it's exciting because it represents that little board chugging away, which was a lot of work. Okay. And I do not work for Osh Park, but I highly recommend the use of KiCad and Osh Park. I can get a board back in a week, $5.80. Again, I do not totally not work for them. I'm just telling you guys this is a tip. $5.80. That's including the postage to your door, USPS. 3 boards. How can you not do that, right? So anyway, this is a little joystick. I'm working with Randy over there on something, but this shows the thing. Let's see. It looks like it's running. So let's see if it's running. And another thing is in the world of high tech, it's good to turn the motor power on. I mean, I'm just letting you know that, you know. So it's not really going to do much of anything. I'm just showing that I can make it move around with a old school joystick, as long as I move it the correct direction. So that's basically it for this guy. But if you want to come and look at it, it's got all kinds of fun stuff on it. And I've had it.
Are you just coding this or using ROS on it?
Oh yeah, so it's got all ROS. It's running the Ubiquity. It's running the Ubiquity Robotics kernel on it, which is a free kernel you can get, and has all kinds of stuff built in. And I stick my own stuff on top of that. It makes for a really fast putting together of your platform. It's got a little OLED display in the back that's running from another one of my little boards. It's a cool little ESP32 based board that does all kinds of fun, cool stuff. I have talked about all those things in the past, so I'm not going to talk about them. But they're all on here. And this thing has been doing the Tablebot Challenge here and some other stuff, and it has the LiDAR to do the mapping that
It's a
has been
wonderful
discussed.
hat.
A lot of stuff.
That's a terrific hat.
But today I'm just showing a little teeny board that plugs into the back. Thank you very much. Wait. Gotta get the name. Okay.
What were the two names that you mentioned? KiCad?
Okay, so layout of PC boards, KiCad, K-I-C-A-D. Like any CAD tool, it takes a while to learn, but it's very flexible, allows you to push around the vias and the traces and all this kind of really advanced stuff because CERN is behind the effort now and contributing heavily to it. Free, completely free KiCad, that's for laying out PC boards. Then I use OshPark, O-S-H-P-I-R-K. When I want to make a lot of boards, I send them to China, but that's a more involved process. OshPark, easy to find. They're in Washington. You send them the CAD files, and bam, within a week they come back. Like I say, the free boards and all that. How can you not make boards? Yes?
I think that's $5 a square inch.
Negative. $5.80 for 3 of these boards delivered to my door, including postage.
Is that?
I can tell you this because I've bought 3 rounds of them, so I know this as a fact.
So, what's the size of the board?
You can come look at it later. This is 35 millimeters by 20 millimeters.
So it's about a square inch. It's $5 a square inch. That's impressive.
Whatever the point is, it's so damn cheap. I'm telling you, 3 boards for $5.80. 10 years ago, if you would have told me about that, or even 20, I would have just said, you're out of your mind. You know, it's great. We're living in a good time. People tell me I'm out of my mind all the time. That's okay. All right. Thank you very much.
Thanks, Mark. Hey, robotics.
Oh. And the other thing I have on my GitHub is a little thing that allows you to run programs automatically as your Pi starts up, or go into reset as a reset, or go into shutdown as holding the switch longer. It's a nice little utility called sysmonitor. All of these things are on my GitHub, and you can talk to me later if you're interested in that sort of thing. Mark-toys.com. Not for sale. Nothing's for sale. That's just my stuff.
All right, Chris. Hello, I actually brought 2 things to show off today. The first thing is drones. I recently got into drones. As some of you know, I joined the DRL challenge to fly an autonomous drone and try to beat human pilots. And actually, 2 of the teammates are here. If anybody's interested in working with drones or autonomous drones, come see us. We'd love to talk to you. What I ended up doing is I bought a little drone. I mean, for $15 you can get these little drones. They're actually pretty cool. I hacked it. The 2-axis joystick is just 4 potentiometers, and you can actually control this with an Arduino very easily. So I have my main desktop controlling this drone and flying it. Of course, I don't let it fly it for very long because there's no feedback. You can get these little guys. It's the same thing. It's the tiny whoop with a camera. These are like $50 to $100. And now you have visual feedback, which is really cool. But for those of you who know me, I'm cheap. So I would rather get the $15 drone. And I found online you can buy these little tiny 1.5 gram cameras that transmit NTSC on 5.8 gigahertz. You can get these for about $4. And there's a lot of YouTube videos that take one of these and glue it to the top or bottom of one of these. And so now you have a drone with full video FPV that you can fly around for about $20. Really, really cool. Now, of course, you either need a headset or you need an app on your phone to get the video feed. But at the moment, I'm controlling the drone with my desktop. I'm getting a video feedback via Wi-Fi. And so now what's left is just a simple matter of software. And hopefully in the very near future, we're going to have real drones, not only in the simulator, but real drones flying through real gates at full speed. So if anybody's interested, come to me. The other thing is, because this puts out an NTSC signal, I couldn't find one. If anybody knows a way to get a standard video feed and turn it into something that's computer readable, to turn this into a frame buffer, please come see me. There's got to be an ASIC out there that can do this. I'm just not personally aware of it. That would help quite a bit. So at the moment, the only feedback of the drones I can get are the ones that give you the image over Wi-Fi. But this is the ones that they fly in the competitions. And that's what I want my computer to be able to fly autonomously.
What's the frequency?
5.8 gigahertz. Yes.
I don't think you mentioned. You said you have your PC is sending signals to the drone instead of using the joystick pad. What is that? An infrared link or a radio link, or how is that?
No, it's I'm talking to an Arduino over the regular USB port, sending actually serial commands to the Arduino, and by varying 4 analog voltages with PWM signals and a resistor, that's all you need. It's controlling the joystick.
Oh, you're hacked into the joystick.
Yeah.
Yeah.
So it's a really simple circuit. It's 5 cents worth of parts, well, plus your Arduino, and that's all there is to it, to controlling your own little drone. It's a lot of fun. Yes.
So is your intention to have the vision processing and the controlling on the drone, or are you going to have a base station?
No. I want the image to come back to the desktop, and all the image processing will be done on the desktop. It will send commands via the serial link to an Arduino that's controlling the controller. So it will fly it. These things are designed to be indoors. I don't intend to fly this outdoors unless it's 0 wind conditions. And they only have about 5 minutes of battery life. The cool thing about this is this uses 3.7 volts, which is exactly what's on these boards, and they actually give you connectors where you can solder in your 3.7 volts directly into the camera. So it's just a quick 5-minute solder job, and you can turn your cheap drone into something with full video feedback, FPV.